Welcome to the short presentation of scientific paper entitled Data Augmentation with GAN to Improve the Prediction of At-Risk Students in a Virtual Learning Environment with authors Tomislav Volaric, RVL Jubik, Marija Dominkovic, Goran Martinovic, and Robert Rzic. The summary of the article was written by artificial intelligence, and the voice used in the video is also the voice of artificial intelligence. Powered by Play Studio. In this paper, we explore using GANs for data augmentation to improve the performance of machine learning models in detecting at-risk students in e-learning institutions. Balancing datasets can enhance machine learning models, but undersampling models but undersampling may lead to data loss. Data augmentation, particularly through GANs, is a meaningful solution for small datasets. GANs generate high-quality synthetic samples within the original dataset's distribution. Detecting at-risk students is crucial in learning analytics, allowing e-learning institutions to support and retain students. We apply this approach to the OLA dataset, commonly used in learning analytics, which includes labeled at-risk students. The OLA dataset presents a moderate challenge due to its relatively balanced nature. After GAN training, a set of 1823 samples was generated to ensure an equal number of non-risk and at-risk student samples. Continuous columns were rounded and scaled back to their original values, while categorical dummy columns were transformed using the itsmax function. Categorical columns were then encoded using label encoding from scikit-learn pre-processing package, and all values in the final result column were set to 0, since only non-risk students' data was used for GAN training. To evaluate the GAN model's performance, classification algorithms were compared on the original and augmented datasets. Categorical columns in the original dataset were also encoded using label encoding. The target column was labeled using a lambda function, marking pass and distinction as 0, and fail and withdrawn as 1. The datasets were split into training and test sets, and the original and generated data were separately scaled using the standard scaler from scikit. Classification algorithms such as XGBoost, random forest, key nearest neighbors, support vector machine, and deep neural networks were employed, and evaluation metrics including accuracy, precision, recall, ROC. The results are presented in Table 1. The results of classification on the augmented dataset were similar to the original dataset, indicating a promising approach for future work. While the generated data closely resembled the original data and balanced the dataset, the performance of the classifiers did not significantly improve. The results might have been more noticeable with a more imbalanced dataset. To further improve the results, parameter tuning for the generator and discriminator networks, exploring different types of GAN networks, or trying alternative data augmentation techniques could be considered. Thank you for attention.